just because Ainsley asked me to, because she's away. Okay, now you have the second coin toss, okay? And so you have to follow each path. If I tossed a head first, then I could toss a head or a tail. We okay with that? If I tossed a tail first, then I could toss a head or a tail. Now, this is a very simple tree diagram, and quite honestly, we're normally looking at probability trees where we have probabilities on the branches, which we'll get to, okay? But often you do have questions about tossing coins, and this is all you need. So because these are equally likely outcomes, there's no need for me to write a half on each branch. Is everyone okay with that? Okay? So what's the probability of two heads occurring? So you might like to write your sample space down the side. Okay? What's the probability of two heads occurring?
1 out of 4.
Okay, there are 4 possible outcomes, and one of them is two heads. What's the probability of one head?
Just one head or
yeah, that would be exactly one head unless specified otherwise. That's a good question. So Joel said, is that saying at least one head? Okay. That means exactly one head unless specified otherwise. It would say at least otherwise. Okay. So one head, there are
2. 1 out of 7. 1, 2, 2 out of 3.
Does this one have one head? No. Does this one have one head?
Yes.
Does this one have one head?
Yes.
Does this one have one head? Okay. Are we good with that?
Yeah.
Okay. So, probability of no heads is
1 out of 4.
okay. That is the same as saying two tails. Now, just throwing it out there, has anyone played that, you know, the coin flipping game? They flip 2 coins and you have to go 2 heads, 2 tails, a head and a tail? You know who played it? Maybe we play it sometime. Okay, so, well, I'm surprised you haven't played it before. I just want everyone to know, because obviously I want to tell you. I always play the winning strategy. Like, because you have double the chance of being correct when you go one either way, right? How many times have I won this game?
0.
Never. Never. I have a winning strategy. Why don't I win? Because it's chance, right? Because chance is involved.
That's why you don't go.
Well, it's like they do it often at trivia as the in-between game. Okay. Okay, so when multiple events are happening successively, that means one after the other. But remember how I mentioned, like if we talked about I tossed 2 coins at the same time, that is exactly the same as me tossing 1 coin and then tossing another, okay? So successively, we treat it as though one thing happened first, but it may have been at the same time. That's okay, all right? So our tree diagram can help us to organize the information, okay? Now, we have this thing called the fundamental counting principle, which you already know. Oh, should I be concerned that I don't know how to spell fundamental? Is it an A?
F-U-N-D.
Is it an I?
No, A.
Okay. Samuel, I find that comment extremely offensive. Do you know in university how many, like, even uni lecturers are like, oh, you're a maths teacher, so you wouldn't know something like English-wise? And I'm like, it's extremely insulting. But anyway, so the multiplication principle is called the fundamental counting principle. It's just the thing we talked about. Multiply it like for Josh's dress-ups, okay? You can multiply successive outcomes together. Now, we'll apply this to our probability tree, where we'll have probabilities on there because the situations will be a bit more complicated. And as we move along the tree, we'll multiply the numbers along the branches. Do I want to say of a particular? I want to say final outcome. Okay. So this think the problem is that this needs changing. So I'm essentially rubbing it into the wall. Okay, so I'm going to draw my tree over here. Thanks, Jane. Okay, a card is drawn from a standard pack of cards and a coin is tossed. Now, even if these are done at the same time, it doesn't matter, okay? We treat one and then the other. We're happy with that? That's really important. People get confused about it. Okay, we're only concerned about the suit of the card. So that means when we pick a card, how many possible outcomes are there? 4, okay? And we're looking at, well, the coin is going to be heads or tails. Okay, so let's start with the card as our first situation. Now, with a tree diagram, it's not like a star, okay? Like you don't want to end up with something like this, right? You want all your branches to end in this beautiful line. So I'll go right up the top and see how they're not the same length, but they end at the same position, okay? It helps to keep your tree in control, alrighty? So I'm going to do hearts, diamonds, clubs, spades here, okay? So that's my cards. Now, we'll come back and talk about the branches in a moment. Now I'm going to toss a coin. Notice how I also haven't squashed them together because this is just the first set of branches and I'm going to have another layer and I need to spread out more. Okay, so give yourself space. When I toss the coin, how many options do I have?
2.
Okay, so out of each of these, okay, so the confusing thing here is that we've got all the, actually I'm just thinking about this, which is interesting because I don't even know that I've quite done a situation like this because, sorry, so these probabilities are a quarter, right? And then these are a half. But in the end, like each of these is equally likely. Does that seem okay? So we don't really need the probabilities on there, do we? There we go. So I'm going to write the sample space. Okay. And so you can see that, like, I knew straight away from the question, I've got 4 options for cards, 2 options for coins. 4 times 2 is 8. I know there are 8 possible outcomes. Okay. So we're looking for probability of a club and a tail. So that's this one here. What's the probability of a club and a tail? Okay, so there are 8 options, and one of them is that. Now, also, you could think of it as 1/4 times 1/2. Okay. Probability of a red card and heads. So what does that mean?
Hearts and diamonds.
Okay, so heart and a head, diamond and a head. Are we happy with that?
So 1 out of 4.
Okay, so that's going to be 2/8 or a quarter. Now, does anyone know when we have 2 branches, so if we had the numbers on there, if we were multiplying along 1/4 times 1/2 and 1/4 times 1/2, how we join the 2 branches together? Does anyone remember that from last year? Yeah, you add them together, okay? So that would be 1/8 plus another 1/8, which is our 2/8. We don't need to do it here, but we'll move on to that later, okay? Next one, not a spade and tails. So that's saying no to spade, yes to tails, by the way, okay? So what are we looking at? Okay, so we've got hearts and tails, diamonds and tails, clubs and tails, but not spades and tails. Yeah? Oh. Probability should not be something that makes you fearful, particularly extension.
It does.
You've got that fear, and it's a right fear that you have of computations and permutations. Don't be fearful of this one, trust me, okay? Oh, sorry. No, but you know that your HSC is on everything, right? So it's still an HSC. Okay, so that's the first lesson. Do you want to have?
Yes.